everyone, in today's video we are going to discuss the thermal power plant and identify the functions of different layout elements. Objectives: at the end of this video you will be able to number 1. Visit the thermal power plant and identify the various stages in the plant. Number 2. Interpret the function of each stage of the thermal power plant. Number 3. Prepare and draw the schematic diagram of the thermal power plant. Note: trainees may visit the nearest thermal power plant to visit the various stages of the power station and learn the functions of each stage from the plant engineer. Before entering the power station, the trainees should be aware of the safety rules and regulations prescribed for the plant areas, like wearing personal protective equipment, not touching any power lines, not touching rotating machines, etc. Let us discuss on thermal power plants. A thermal power station is a type of power station in which heat energy is converted to electrical energy. The most prevalent type of thermal power plant in the world, thermal plants produce roughly 60% of the world's electricity. Coal, natural gas or oil-fired boilers are used to heat water and generate steam. The steam is then used to turn a turbine which is connected to a generator that produces electricity. It is necessary to cool the steam after it leaves the turbine, condense it back into water and then circulate it through the system. In India, the electricity generated by thermal power plants accounts for up to 71% of the total power generation. Now let's discuss each part of the thermal power plants. Step 1. Visit the stages of a thermal power plant. A. Coal and ash handling arrangement. Number 1. Tipplers in the coal handling factory unload the coal from the coal wagons. Number 2. Conveyor belts are used to move this coal upward to the coal storage bunkers. Conveyor belts are used to transfer the coal to the crushing house, where it is broken into small pieces and light dust is extracted. Number 3. Coal feeders then deliver the crushed coal to the bowl mill. Coal is processed into powder in a bowl mill. Coal particles fall on a circular metallic table inside the mill. A mixture of hot and cold air is then used to transport the crushed coal through coal pipes to the boiler. Ash handling arrangements. Ash handling systems are mechanical devices that correctly dispose of the ash. So after the coal has been burnt, the ash from the coal is collected and disposed of. Before disposing of it, it must be cooled down to a manageable temperature. It is then transferred to a disposal or storage area and used in various industries such as cement plants, construction and other similar places. The residual product, which may contain ashes or gases, will be collected by an electrostatic precipitator, that is ESP, and stored in the hoppers at the bottom of the ESP. B. Steam generating plant. A steam power plant consists of a boiler, steam turbine and generator and other auxiliaries. The boiler generates steam at high pressure and high temperature. The steam turbine converts the heat energy of steam into mechanical energy. The generator then converts the mechanical energy into electric power. C. Steam turbine. A steam turbine is a machine that extracts thermal energy from pressurized steam and uses it to do mechanical work on a rotating output shaft. The steam turbine is a machine that, categorized as a form of heat engine, can extract thermal energy from steam and convert it into rotatory motions. D. Alternator. The alternator used in thermal plants are termed as turbo alternators, as they are coupled to steam turbines. Turbo alternators have cylindrical rotors, hence a uniform air gap exists between rotor and the stator. Steam heat energy is converted into mechanical work by the turbine and mechanical energy is converted to electrical energy by the alternator. Three-phase turbo alternators operating at a frequency of 50 Hz. E. Feed water supply. Feed water is water that has been purified or heated before being given to boilers to produce hot water and steam. Boiler feed water is the water that is given to the boiler and turned into steam. F. Cooling arrangement. Condenser and cooling towers make up the majority of the cooling system. In order to increase the power plant's overall efficiency, the condenser is utilized to condense the steam exhausted from the turbine. Step 2. Identify the following constituents of a steam generating plant and write down the functions in table. Constituents: A. Boiler. Type: ultra high pressure boiler, 13.7 megapascal, less than equal to pressure less than equal to 16.7 megapascal. Function: boiler is an enclosed pressure vessel in water is converted into heat by gaining from the coal. Here, combustion takes place at 1300 to 1700 degrees Celsius. Superheater. Radiant type. Superheaters and reheaters are specially designed to increase the temperature of a saturated steam and to help control the steam outlet temperature. C. Economizer. Non-condensing type. An economizer is the device in which the waste heat of the flue gases is utilized from heating the feed water. D. Air preheater. Regenerative type. The main function of an air preheater is to extract excess heat from the flue gases in the boiler. E. Condenser. Surface condenser. A steam condenser is a closed vessel heat exchanger that is used to convert low pressure steam into water. It works to achieve two main objectives: to supply pure water to the hot well. Water from the hot well is again pumped into the boiler with the help of a boiler feed pump to maintain pressure below the atmospheric pressure at the outlet of the steam turbine so as to obtain the maximum possible energy. F. Cooling tower. Induced draft cooling tower. The purpose of a cooling tower is to reduce the hotness of water steam by expelling high temperatures from the water and then transmitting them to the air. Water treatment chamber. Reverse osmosis. Chamber filtration removes various particles from water. The feed is transferred from the feed tank into the chamber filtration unit where the water is filtered. Chamber filtration removes various particles from water. The feed is transferred from the feed tank into the chamber filtration unit where the water is filtered. Thermal power facilities use water treatment to avoid issues including carryover to turbine components as well as corrosion and scale formation or deposition in the boiler and turbine systems. Step 3. Trace the various parts of alternator and note down the nameplate details. Number 1. Number of phases 3. Number 2. Capacity 100 kilovolt ampere. Number 3. Speed 3000 revolutions per minute. Number 4. Output voltage 440 volt. Number 5. Current 250 amperes. Number 6. Frequency 50 hertz. Number 7. Excitation current 36 amperes. Number 8. Serial number. Number 9. Year of manufacturing 1996. Number 10. Model number. Step 4. Draw the schematic diagram of thermal power station you visited. In this video, we have discussed the layout and different parts and equipments in a thermal power plant. I hope after watching this video, you can identify the parts in a thermal power plant. Thank you and have a wonderful day.